Alright, building off the last topic on perpendicular vectors, we are moving on to vector components. Vector components are very similar to what we've been doing, so this is not one that should take us very long. When we're looking at it, we know that every single vector, regardless of direction, has a horizontal component and a vertical component. So in example 1, it wants us to find the horizontal and vertical components of each vector. The way this is done is A, B, C, D are done together, and E, F, G, and H. So let's look at A, B, C, and D first. So on A, B, C, and D, we have the components. Let's say we are going 22.5 meters east. We can go 22.5 meters west, 22.5 meters north, and 22.5 meters south. When we're looking at these, we have our horizontal and vertical components of all four. So in the first one, I'm going to decide to make, and this will be for all of this page, let's make north positive, east positive, south negative, and west negative. So if we are heading in the direction of 22.5 meters east, our dx, or our horizontal component, is 22.5 meters, and our vertical component, there's nothing going up and down, so it's just 0 meters. Same thing here when we're heading west. Our horizontal component is negative 22.5 meters because we decided to make west negative. And then we also have our vertical component of 0 meters. Now when we're looking on the other side, now we only have vertical components. We don't have horizontal components. So on this one, the pen's not working very well. On this one, we have our horizontal component is 0 meters, and our vertical component is positive 22.5 meters because it's headed north, and we made north positive. The opposite is true for south. We have our horizontal component is 0, and our vertical component is 22.5 meters, so that's negative 22.5 meters because it's headed south, which we made negative. That part is pretty straightforward, pretty easy. The next part is not all that tricky either. So when we're looking here, again, I'm going to make my directions. I'm going to make north positive, east positive, south negative, and west negative. That's not as important as now when we're traveling at an angle. So we are headed at 22.5 meters northwest. So remember, that means we're going to start at west and head north. So our line is going to be in this direction. That's going to be 22.5 meters. We can also head west of south, right? So we start south and head west. That's going to be in a direction like that, 22.5 meters. South of east means we're going to start east and head south. And east of south is, I'm going to change this to east of north. So we're going to move in this direction. All right, again, those are both 22.5 meters. So on these, we now have horizontal and vertical components. They're not as easy to see right away, but we need to draw them out. So on this one, our horizontal is going to be our x component, and our vertical is going to be our y component. So to find our horizontal, this is like the lab that you did last week. There you know, using cos of this angle, which is 35 degrees north of west, cos of 35 degrees equals our x component divided by 22.5 meters. The reason that works is because we use SOHCAHTOA. The SOHCAHTOA, the Ka part, is cosine is equal to adjacent over hypotenuse. Cosine is equal to adjacent over hypotenuse. So when we rearrange that, we have dx is equal to cos 35 times 22.5 meters. That's going to give us an x component of negative 18.4 meters, which makes sense. We made negative heading to the west. We also need to figure out our vertical component. So to do that, we're going to use sine. Because the sine of 35, sine is it's opposite over hypotenuse. So sine of 35 is equal to dy over our hypotenuse, 22.5 meters. We rearrange that for dy is equal to sine 35 times 22.5 meters, and our y component is equal to 12.9 meters. That's all for question E. So let's go ahead now and let's look at F. We are now heading 35 degrees west of south. So that means we're heading west of south. Right here we're headed 35 degrees west of south. Alright, so we already know that we're going 22.5 meters west of south, but that means we are going to have our x component heading west and our y component heading south, just like is given in the directions, west and south. Alright, so to find our x component, I'm not going to rearrange like I did up here anymore because we've done a bunch of examples and I think it's pretty straightforward at this point. But when I plug in, I have my x component is equal to 22.5 meters times the cosine of, well, now this is different. On the outside we have 35 degrees, meaning our angle here is actually 55 degrees. These two angles add up to 90. So that's the cos of 55 degrees. So our x component is equal to negative 12.9 meters. So now we're going to find our y component. Our y component, again, I'm not going to rearrange because you've done quite a few examples now. We are going to take 22.5 meters and multiply times the sine of 55 degrees. So the y component is equal to negative 18.4 meters. That makes sense. This here is negative 12.9 meters. It's headed west. And we have negative 18.4 meters on our y component headed south. Both answers should be negative. Perfect. Alright, so moving on to these next ones here. It's just going to be rinse and repeat. So I'm going to leave these ones blank on this video, and I'm going to allow you guys the opportunities to complete those on your own. But I will have the scans of them ready for you to go on Canvas.